This video is about finding the equation of a tangent to a curve graphically, as well as using the facility in the calculator window. So we'll begin by opening up a new document, the calculator window, and define a function f of x equal to, and we'll choose e to the power of cos x. Having done that, go to Menu, Calculus, Tangent Line. Now we enter in the function f of x at this point. We're wanting the tangent line. The derivative, of course, will be worked out with respect to x, and we'll work out the equation of the tangent line at pi on 4. That's at x equal to pi on 4. And there it is. That's the exact value, but a much more readable version is this one here. There's the equation of the tangent. Needless to say, it's y equals this. Gives a fair few decimal places. This is the advantage of doing the tangent line in the calculation window. You can set the number of decimal places to your needs. If you want to do this graphically, just go over here, type in f of x, and it shows the full function on the available window settings. Now if we want the tangent, we go to Menu. I'm going to go to Geometry and select Points and Lines with Point On, so that we can actually see the coordinates of the point we're working with. Let's get that out of the way. And here is our point, and we want to put a tangent line to that point. So we'll go to Menu, Geometry, Points and Lines again, and then Tangent. And just zoom in there. And there's our tangent line. Now you'll notice that this is not the one we had earlier on. Needless to say, this is not pi on 4 in here. So we can change it to pi on 4. There's the exact value on display, and there's the equation of the tangent line. Now you'll notice the very first thing is the limited number of decimal places. You cannot change this particular output provided by the CAS device. You are dependent on this here to be able to change the decimal places that you choose. So if you're asked to give the equation of the decimal of the tangent with the coefficients to say 4 decimal places, don't depend on this. It's not going to give you what you require. But it does give you a visual take on what's going on with this particular curve and its tangent lines. The advantage also is that you can grab the tangent point and watch the equation of the tangent line change. Might be valuable evening's entertainment, just mucking around with this. Back to the first page. This is the final equation that we sought. Yeah, we can also at the same time work out the derivative of the function at any point. So here we go, just enter it into there. Our function f of x, hit enter, and there you've got the derivative. Well, that ends this instruction procedure on finding the equation of tangents to curves. Now, while we're on this video, we might just quickly review how to find the gradient of a secant to the same curve at 2 different points. Supposing we wanted to find the gradient of the secant joining the points pi on, where x is pi on 8 to x equals pi on 4. Well, needless to say, this procedure is fairly straightforward. Go up to here, type in f of pi on 4, f of pi on 8, and down the bottom this will be pi on 4 minus pi on 8. Now I could just copy this as pi on 8, place it straight into there, but I'm going to copy the whole thing. I can't. Okay, so we'll go into here, just retype it, pi on 4 minus pi on 8. This is not really necessary, you just type on pi on 8 directly, but it's done to impress the fact that this is the f of x2 minus the f of x1 over x2 minus x1. So just hit Control Enter, and that will give you the value to so many decimal places. Of course, if we just hit Enter, you would get the exact value. So we could do that, copy that, paste it here, Enter, and it gives you the exact value. Not particularly useful to work with, but there it is, should you wish to have it.